While networks are tools for connection, their structural integrity relies on exclusion. To secure data, an architect must determine who the network keeps out. This is the access boundary. It functions as the operational perimeter that separates an organization's private assets from the public sphere. Network architects face a constant, inherent tension. They must satisfy an organization's demand for global connectivity while maintaining the absolute isolation required for internal security. By examining how these security perimeters are drawn, we can map the design of the three major network types used in modern enterprise. Where this boundary is placed determines an organization's operational reach and its specific exposure to risk. The first model is the Intranet, the most closed, strictly secured architectural design available. The second is the Extranet, a semi-trusted hybrid model bridging specific gaps between partners. The third tier is the Internet, an unbounded global mesh designed for public access without pre-existing trust. Moving between these three tiers requires architects to accept distinct structural trade-offs. Expanding a boundary improves communication efficiency, but it shifts the burden of infrastructure costs and security risks onto the organization. Understanding these three tiers is essential because no single networking model can meet every operational requirement. This diagram illustrates a private intranet. Notice how the entire network is completely contained within the organizational loop. The central network server acts as the sole mediator of communication. It routes local traffic exclusively between these connected PCs. Within this closed system, every computer is assigned an IP address. However, that address is only unique among machines inside that specific intranet. The outside world cannot route traffic to it. This isolation is enforced by a firewall. It is the defining architectural feature that severs the local network from external internet traffic. Because the environment is entirely controlled, administrators can maintain platform independency across different device architectures and push real-time updates to all internal employees. The Internet prioritizes security and internal productivity by removing external reach from the equation. This chart categorizes the primary organizational advantages of this network structure. These benefits cluster into three operational pillars: secure communication, cost efficiency through digital document distribution, and dedicated workforce productivity tools. However, building and maintaining this closed infrastructure from scratch introduced significant complexity. The primary structural disadvantages of an intranet are high initial implementation costs and the heavy management overhead required to operate private servers. There are also human factor risks. These systems frequently suffer from a poor user experience, leaving employees overwhelmed by separate administration tasks. This often leads to low user adoption. A secure walled garden provides zero value if the employees find it too complex to navigate and refuse to use it. This raises a core architectural problem. How does an organization securely exchange real-time data with an external supplier without exposing its entire intranet to the general public? The solution is the Extranet. This is a private network that has been intentionally and selectively open to authorized third parties. This architecture grants specific access to business partners, suppliers, and key customers, while keeping the rest of the firewall intact. For modern businesses, this is an operational necessity. It enables immediate online ordering and electronic order tracking directly between distinct corporate entities.
By adopting this technology, larger companies can automate business-to-business trading tasks and maintain 24-hour supply chain integration. Extranets sacrifice a highly controlled degree of isolation in order to achieve operational efficiency with trusted partners. Finally, we expand to the global internet, the largest scale possible, linking millions of computers globally. The history of this global structure begins with the creation of the Advanced Research Project Agency, or ARPA, by the United States Defense Department. The physical architecture making this global scale possible relies on high-bandwidth backbone data lines. These cables dictate the maximum data transfer rate of the network. From that backbone, Internet hubs distribute data to Internet service providers. Those ISPs then act as the link to the end user, routing data down to local Wi-Fi routers and cellular towers. This open architecture delivers significant benefits, including global audience reach, access to unlimited information, and a low-cost medium for communication. The Internet is designed for universal, frictionless accessibility. However, the very openness that allows for global reach is also what creates its inherent security risk. The moment a system connects to the public Internet, it loses the inherent security guarantees of a private Intranet. Opening the boundary introduces systemic technical threats. Systems are suddenly exposed to active hacking attempts, unauthorized access, and the deployment of malicious virus programs that can crash entire systems. This creates severe data-level vulnerabilities, specifically the theft of personal information, confidential corporate data, and critical financial records. The network is also susceptible to communication attacks, like spamming, where massive volumes of unwanted emails are sent intentionally to harass users and overwhelm computing resources. Beyond the technical risks, unlimited digital access produces behavioral side effects, including time wastage, internet addiction, and diminished interpersonal communication skills, resulting from social isolation. Operating on the Internet requires an organization to actively construct and defend its own borders, because the public network itself provides zero inherent security. By mapping these three models onto a coordinate plane, we can see the inverse relationship between a network's reach and its level of control. The Intranet sits in the top left quadrant, focused on high-security internal operations. The Extranet occupies the exact center, balancing moderate security with specific external reach. And the Internet sits in the bottom right quadrant, representing maximum reach with the lowest inherent security. Expanding a network boundary is never free. It is a continuous, calculated trade-off between organizational control and global accessibility. There is no single universal network type. There is only the correct architectural choice for a specific operational goal. Intranets exist for internal productivity. Extranets facilitate secure business-to-business collaboration, and the Internet provides public scale. A successful modern enterprise does not rely on just one of these models. It must integrate all three to function competitively in the global economy. The role of the network architect is to rigorously manage the gates between these different scopes of trust, ensuring data flows exactly where it needs to go and nowhere else. In the modern digital landscape, knowing how to connect devices is the easy part. Knowing exactly where to draw the boundary is everything.